In order to complete this project, we need to be able to read in all of the parse trees that were created as part of the child's project for a particular speaker and convert the text that describes what those trees are into our data abstraction of phrases and words. So the data lives in a file. We'll talk just a little bit about how to get data from a file into the Python environment. Some files are plain text, including the ones from this project, and therefore can be read into Python as either one long string containing the whole contents of the file, which you do by calling the built-in open function, where you pass in as a string the path to that file and then .read it. We're not going to use this one. Instead, we'll use another one, which returns a list of strings, each containing one line from the file, which is almost the same. You open the file and then you read its lines. And before you start processing the contents of a file, it's a good idea to look at it. Less is a program that just shows you the contents of a file. And here we see sentences uttered by some child like, "This is a book." "What do you see in the book?" So actually these are conversations between children and adults. I'm a little hazy on the details, but I think some of these were said by children. Anyway, here's the format. One sentence can span multiple lines. The words are in there somewhere, but the structure of that syntactic parse is also annotated using parentheses. Everything has a root. That's not very interesting. But this tells us what kind of sentences it is. Declarative, a question, a fragment, meaning part of a sentence. And then we see many of the other structures that we talked about, like a verb phrase, which goes all the way from here to the matching closing parenthesis, which I think is probably this one. So to make any progress on turning this into our tree data abstraction, I think we need to get all this information for the whole sentence in one long list, where the list contains things like parentheses, the word root, the word what, closing parentheses, and then we could turn that into a tree. In order to set ourselves up with this useful list, we're going to have to use a few string methods for processing the contents of a file. One is strip, which is built in. When you strip a string, you're returning an equivalent string without any white space on the ends. If I strip the spaces off of the beginning and end of hello, I just end up with hello. Split returns a list of strings that were separated by white space for an original string that has some white space in it. So if I split up hi there, then I get hi and there. There are actually two spaces here. That's okay. Any contiguous white space is used as a separator. And the third is replace, which returns a string with all instances of the substring A replaced by string B. So for example, if I had 2 plus 2 as my original string and I replaced the plus with spaces around it, then I'd get 2 space plus space 2 because I replaced the plus with this length 3 string. And these three operations are used in combination in order to get rid of the extra white space, then split things up into a list. But before you do that, you want to make sure that plus ends up as its own element in the list by putting spaces around it. So here's what we already wrote. I'm not going to write all this code, but I'll show it to you. Here are a couple of examples from the file. When I have a list of lines from the file, I can get lists, one per sentence, as follows. I build a list of sentences where each is a list of tokens. The tokens include parentheses, tags, and the text of the words. For every line, if it's the case that stripping off the white space from the beginning and the end leaves anything at all, then I extend the list of tokens I have so far by taking the line and splitting it up. But right before I split it up, I replace the parentheses by versions that have spaces around them. And what's that doing? Well, that's making sure that everything is nicely spaced out so that the parentheses end up as their own elements in the list. This line says if the token count for open parenthesis is equal to the count for closing parenthesis, we've gotten to the end of a sentence. If I'm only at this line, that won't be true, because I haven't found the closing parenthesis for the original opening parenthesis. It's only till I get to this line that I've found enough closing parentheses to close the open one that I started with at the very beginning, at which point I take the tokens that I have and call that a new sentence and start again for the next sentence. To get all the sentences, I call read sentences on the result of opening up this file full of examples and reading its lines. So if I look at the first 10 lines of this file, which is what the program head does, I see two examples. It should be the case that when I get all the sentences from that file, of which there are over 35,000, and I look at the element at index 0, I now have a list that represents this one. Open parenthesis, root, etc., etc. This is a book, question mark. Here's a useful Python list representing what was in the file in the first place with a few lines of code. Next, we'll have to figure out how to turn it into a tree. So here's a different sentence. Is that a big bug or a little bug? I've made the words blue so that you can follow along. This list contains all of the syntactic structure. And here's part of it, the part about a big bug. Here's how I turn this into a tree. I'm going to write down a function, read parse tree, for some tokens. This is the list of tokens. Starting at some position I, which is going to be the tag for the constituent that I'm trying to construct a tree for. I'll read the tag, which is tokens I, then advance I, and take a look at what I'm dealing with next. While the current item is an open parenthesis, I just need to repeat the process of reading in one constituent, which I can do recursively by calling read parse tree. That constructs a branch with another branch with big, another branch with bug, and now I've reached the closing parenthesis, which is the stopping condition. I know I've reached the end of this phrase because I've matched it up with the opening parenthesis that I had before, and so it's time to return a phrase from the tag and branches. Now there's more stuff to do, because this would have been one of many recursive calls that figured out how to build a tree for a big bug. But after that, you have to build a tree for or and for a little bug, and then take those and put them together into a noun phrase and put that as part of the sentence, which is part of the root. So we need to worry about two things. What's the base case and what do we return? The base case is when you get in here and notice that there's no opening parenthesis at all. There's just text there. That's a word. And how do you know where to keep going after you've finished? Well, read parse tree needs to return the tree that it just constructed for the tag that corresponds to I that was passed in. But it also needs to return what to read next, which means it's going to return a new I that tells you how far this has advanced while reading this noun phrase. And if it tells you that, then you know you're ready to read whatever's next. Let's actually implement this one. How do you go from the tokens, that is the list we've created, to a parse tree? Token 0 better always be an open parenthesis. We're going to read a parse tree starting with the tag for that whole sentence, position 1, right after the open parenthesis. This is going to give me back the result that I want, the tree. It's also going to give me back the position at the end of the whole sentence, which I actually don't care about. The only reason I'm returning this value is that it's important for the recursive implementation of read parse tree, which takes in the whole list of tokens as well as the position where I need to start reading. Right there we have the tag. Then I advance I, like I said. Now I should be looking at the opening parenthesis for the next phrase, unless I've hit a base case and there's just text there. If tokens I does not equal an opening parenthesis, then I'm looking at some text followed by the closing parenthesis for the word, and so I build a word from the tag, from the text, and I've used up the tag, the text, the closing parenthesis, and I'm ready to continue after that. If this isn't the base case, then I need to build up my list of branches. While it's the case that tokens I does not equal the closing parenthesis that matched the original opening parenthesis, it better be the case that tokens I is a brand new opening parenthesis for a new constituent. So what do I want to do? I want to read that constituent. So I call read parseTree on the same tokens as before, but now I want to start just after this opening parenthesis. What do I get back? A branch, as well as the position where I'll either see another branch or the closing parenthesis. I'll call that I. Branches.append B. And after all that, we can return a new phrase with the tag that we started with and the branches we've constructed, as well as the position where read parseTree should pick up for the next constituent, which is just past the closing parenthesis. Did it work? Apparently it did. So now, if I get all the sentences and I call tokens to parseTree on the first one, I get what looks like a tree. And I can even print it out and see its structure. Progress.